Hello friends, in this lecture we're going to start working on the enemy spawner. The enemy spawner is going to be a big class, so it's going to take us a couple of episodes to finish, and in this first one we're going to implement the main functionality of the enemy spawner, which is going to be spawning enemies. But we're also going to place some responsibilities like restarting the game when the player loses and keeping track of the score on the enemy spawner, so it's also going to be like a manager class. Okay, so let me explain how the enemy spawner is going to spawn enemies. First of all, the enemy spawner is going to get the size of the game area from the camera, so it's going to know how big the game area is in terms of width and height. Then it's going to pick a random position on the edges of the game area, so that could be here, here, here. It's going to use a random number to get this location. After it picks a random spawn position, it's going to spawn an enemy, place it at this location, it's going to spawn it at this location, it's going to give the enemy a random sprite, so that each enemy looks a little bit different and they don't look all the same. It's going to calculate the direction for the enemy, and we're going to do that in two ways. We're going to do it based on the center position, so that the enemy goes towards the center, and we can also do it on the position of the player so that the enemy goes directly at the player. And there's going to be room for improvement here. So you might want to create a system that picks a completely random direction. So that might be something you want to do. Like I said, this is going to be the basic way the enemy spawner works. So let's go ahead and get started. So first of all, we're going to create a new C++ class for the enemy spawner, which is going to be an actor. Enemy spawner. I created this already so that we can save some time, but you should go ahead and create this. Now we're going to switch over to Visual Studio and we're going to lay down all the code that we need to successfully spawn enemies. We're going to have to include some headers up here. The first one is going to be the timer. We're going to have a bunch of timers in this class. And then we're going to include some of the ones we created, like the player and the enemy. Just like that. Now we're going to create the variables. So first of all, we're going to create the game area size, which is going to be visible anywhere, and we'll make this blueprint read only. This is going to be an f vector 2D called game area size. The second variable is going to be an edit defaults only, so that we can only change this from the blueprint and not in the map. And this is going to be the enemy class that we're going to use when we spawn the actor. And this has to be a type of T subclass of a enemy, and we're going to call this enemy actor to spawn. This is just how Unreal wants us to create this, and without this we can't spawn the actor, so this is important. Next up, we're going to create an array of sprites so that we can get a random one when we create an enemy, and these are going to be edit anywhere, and we'll make these blueprint read write. This will be a T array of view paper sprite pointers, and we're going to call this enemy sprites. Next up, we're going to create the spawn time float, which is going to control how fast we spawn enemies. It's going to control the time between the intervals. We'll set this to be like 3. We can always change it later on. And this means we're also going to have a timer, of course. So we're going to have a spawn timer. And we're also going to create a variable to hold the player. So we'll say a player character pointer player. So those are all the variables we're going to create. Now let's get to the functions. And first of all, we're going to create a set of functions that are going to control the spawning. So we'll have one called start spawning, one called stop spawning, and then one called spawn enemy. These are pretty much self-explanatory. This will start the spawning, this will stop the spawning, and they're going to do that using the timer, and spawn enemy is going to spawn a new enemy into the game. We're also going to create a function for the spawn timer to call, and that will be on spawn timer timeout. Okay, so that's all we're going to create here. Let's go ahead and create these functions. Okay, I think I will put this one above spawn enemy actually. And first of all, we're going to do a couple of things in the begin play function. I want to get the camera actor, and then I want to get the width of the camera and the height of the camera and use those as the size for the game. So that's going to be the first thing. And the second thing we want to do is we want to get the player, and we want to set the horizontal and vertical limits of the player using those sizes. So beforehand we were actually doing this by using these hard-coded values here. So now we're just going to comment these out. We're not going to use these anymore, and we're going to do this in the spawner. Okay, so to be able to do this, we're going to include some stuff, which are mainly going to be the camera actor.h, the camera component.h, and also we're going to include the gameplay statics. That's going to be Kismet gameplay statics.h. So first of all, let's do the camera. So we'll say get the game area size from the camera. In order to get the camera, we're going to make a call to gameplay statics get, let's see, did I mistype that? Gameplay statics, maybe like that. Yep. Get actor of class. This is going to search the whole world, and then it's going to return us this type of actor that we're going to provide if it finds one. And here we're going to pass, let's see, camera actor static class, a camera actor. It's like that. So it's going to try to find an actor with the class a camera actor, and then it's going to return it. But it's going to return, let's see, an actor pointer. So we're going to store that in an actor pointer called the camera search. And if the camera search is not null, that means it worked. We're going to cast this to be a camera actor, and then we're going to get the camera component from the actor, because that's what we ultimately need to get the width. Okay, so we'll say a camera actor pointer. Camera actor is cast. Let's cast it to be an a camera actor. The camera search. And then we can get the camera, let's see, is it U camera component. We'll say CU, and we'll get the camera component by calling get camera component, just like that. Okay, we did all of these so that we can call CU ortho width. This is what we want. So we're going to say game area size.x equals the ortho width, and then the y, the height, is going to be the ortho width divided by the aspect ratio, which is also something we can get from the camera component. Did I say CU? Why did I do that? It should be CC. I think I was thinking of this U here, but you know, it's too late now. It's going to be CU. Okay, so this is going to give us the correct game area size that we need to use in the game. And we can even print this out using a log if we are curious and we want to see this. So we'll say log temp display, and we'll create a text with two floats, which are going to be game area size.x and game area size.y. Okay, so that should be all good. And the second thing we're going to do here is give the player the limits. We'll basically do the same thing here first of all. So let's actually just copy and paste all of this stuff. And we're just going to change this to be player search. And we're also going to change the class here to be a player character. Okay, let's also change this to just player because we have this variable created already in the class. And we're going to cast it to be an a player character as well. And in here, all we want to do is we want to set the player horizontal limits .x and .y. And also the same thing for the vertical limits. And the x for the horizontal limit is going to be the game area size divided by 2 negative, and the y is going to be positive, the same thing, because the center of the game area is 0, 0, because that's how we set this up. So if the game area size here, the whole thing is 1280, that means this end here is negative 640, and this end here is positive 640. So those are the limits we're going to assign, and it's the same thing with the y here. If this is 720, up here is going to be 360, and down here is going to be negative. So this is positive, and down here is going to be negative 360. So that's what we're going to do here. So here, let's say game area size.x divided by 2, negative, and down here we'll just do the same thing but positive, and it's going to be same here for the vertical limits, but we're going to use the, let's see, the y component, and up here it's going to be negative, and down here it's going to be positive. Okay, hopefully we did the right thing here. We can test it later on using different camera sizes to make sure it works. But now that this stuff is complete, we can actually get to the main, functionality of this, which is going to be right here. So in order to start spawning, we're going to set the spawn timer. And each time the spawn timer times out, it's going to call this function, which is simply going to call spawn enemy. That's all it's going to do. So first of all, let's go to the enemy and get this line of code here so that we don't have to type it out again. And in here, we're going to start the spawn timer. And we're going to give it this function. And also we're going to use the spawn time here. Kind of a similar name. I should have just said spawn timer duration, but whatever. And this time, we're going to make it loop. So we're going to say true here. And because we're making it loop, we need to also use this float here. So I think I explained this before, but the timer, the first time it starts, it's going to use this time. And after it times out once, it's going to start using this one. So if you only provide one of these, you're going to get confused. So make sure you have both. And in stop spawning, we're going to make a call to clear timer, and that's going to just stop the timer. Okay, so let's actually call start spawning in begin play here. So we'll start spawning right away at the start of the game. Okay, so spawn enemy, this is going to be one big function. And the first part of the function is going to be calculate a random position, spawn position for the enemy. And then the second is going to be calculate the movement direction for the enemy. And the final part is going to be spawn the enemy and set it up. Okay, so in order to get a random spawn position, we're going to create a variable to hold it, of course, which is going to be an f vector 2D, or maybe we should just make it an f vector. We'll just make it a 2D. We'll call this the spawn position, and at the start we'll just set it to be 0, 0. And then we're going to pick a random position on the edges of the game area. And in order to do that, we're going to get a random float, and based on that float, we're going to do different things. So, okay. Let me just get that float, which is going to be, let's say, spawn chance, and this will be an fmath frand. This function is going to, let's see, we forgot the semicolon there. Okay, so this function is going to return a floating point number between 0 and 1. That can be 0.5, 0.6, 0.453, any number in between. If this number is less than 0.5, so okay, if that number is less than 0.5, we're going to pick one of these two sides to spawn the enemy, and if it's greater than 0.5, we're going to pick one of these sides. And the interesting part here is that if we pick one of these sides, the x position is going to be the same, and then we're going to pick a random y position in this range. And if we pick these sides, the y position is going to be the same. It's going to be either here or here, and then we're going to pick a random x position. And after we pick one of these two, for example, we're also going to pick one from each of these. So we're going to either pick this one or this one. Okay, so let's go back in here. In this case, we're going to say spawn position dot x is going to be game area size dot x divided by 2. And if the spawn chance is less than 0.25, we're going to multiply this by -1. So this is going to make it so that we're going to pick the right side, and if the spawn chance is less than 0.25, we're going to pick the left side. Because as you remember, this whole length is game area size at x, and here is 0, so this would be game area size divided by 2, and this would be game area size divided by 2 but negative. So that's what we're using here. We're picking the right edge, and if the chance is less than 0.25, which is also going to be another 50% chance here, we're going to pick the left edge. And we're going to do the same thing down here, but this time with the y. So let's just copy and paste the y here. And this time we're going to check for less than 0.75. Because if we're in this else statement here, the spawn chance is between 0.5 and 1. Here it's in between 0 and 0.5. Okay, and finally we're going to pick the y, which in this case is going to be a random number in this range, which is going to be negative game area size dot y divided by 2 and positive of that same number. Hopefully this is clear. I feel like in my head that this is getting too complicated for you guys because of how fast I'm explaining it, but hopefully it's all clear. If it's not, just leave a comment and I'll try to explain it a bit more. So this is going to be an f random range, which is going to give us a floating point number from the range we provide. And in this case, it's just going to be game area size, negative game area size dot y divided by 2, and then the positive of that for the y, and down here we're going to do it for the x. Okay, at this point we have a random spawn position. Now we're going to calculate the direction for the enemy. And we're going to do this in two ways. The first is going to be sending the enemy to the center, and the second is going to be sending the enemy at the player. We're going to create an f vector 2D for the movement direction, And by default, we'll just set this to be 0. We're also going to create an F vector 2D for the center position, which is going to be 0 and 0 in our case. But if for you that's different, just enter it here. And the way we can get the direction vector is very simple. So let's say that you want to get the direction from the enemy to the player. Then you want to take the player's position vector and simply subtract the enemy's. So you take the second one and then you just subtract the first one. Very simple. So we're simply going to say movement direction equals the center position minus the spawn position, just like that. And the second way we can do this is by getting the location for the player, which is going to be an F vector this time. And we can say player get actor location. And then we can say movement direction equals the player position minus the spawn position. But of course, we're not going to be able to just subtract these. We have to create an F vector 2D. And make sure to use the Z instead of the Y. And finally, we need to normalize this movement direction, because when we normalize it, it's going to have a length of 1, so that we can use this in our multiplication in the movement, so that it doesn't change how fast we go, it simply gives us direction. And finally, we're going to spawn the enemy. That's going to be a call to the world spawn actor. The class is going to be a enemy. And this is going to take in the enemy actor to spawn. Then it's going to take in the position, which is the spawn position. But we actually need to turn spawn position into an F vector. So we'll say .x, 0 for the y, and .y. And finally, we're going to provide the rotation, which is going to be F rotator, 0 rotator. This call is going to create the enemy and it's going to return it to us. So let's save that in a variable, and then we can check if it worked. And if it did work, we can do some setup here. And the main thing we need to do is we need to give the enemy its direction. So we'll say movement direction equals movement direction. That's very important. And the second thing we're going to do is going to be giving it a random sprite so that each enemy looks a little bit different. So to do that, we're going to get a random integer so that we can use that as the index for the variable, for the array we have here, the enemy sprite array. That's going to be random index, let's say. We're going to use another function from the math class, which is going to be rand range. And the range is going to be from 0 to enemy sprites.num minus 1. So whatever is the size of the enemy sprites, in this case 3, we're going to subtract 1 from it, and that's going to be the range. So in this case, that would be 0, 1, 2. Those would be the numbers we get from this. And then we can use that with enemy sprites, random index, like that, to get a random enemy sprite each time. And we can simply say enemy sprite component set sprite, and then we can do that. Okay, so that's going to be all we need to do in this lecture, in the code at least. It was a lot. Hopefully you were able to keep up, but let's go ahead and exit out of Unreal, rebuild the project, and then we're going to create a blueprint for the enemy spawner, set it up, configure the blueprint, and then test it. So let's go ahead and create a blueprint for this. Enemy spawner. We're going to call it blueprint underscore enemy spawner, following the same naming convention. Let's open it up. We're gonna have to set the enemy actor to spawn and the enemy sprites. This one is going to be blueprint enemy. Make sure to pick the blueprint and not the regular enemy. Pay attention to that. And for the enemy sprites, we're going to create 3 elements here and pick the ones we have inside of our assets, just like that. We can also change the spawn time if we want to from here, which is good to know. Let's save and compile this and bring it into the game. We can also get rid of this enemy that we created. We don't need that anymore. And let's also put the enemy spawner at the origin of 0, 0, 0. Awesome. Okay, so let's take a look at the camera. Currently the ortho width is 1280, so the game area size should be 1280 by 720. I'm going to play the game. And first of all, I'm going to check the logs. As you can see, the spawning is working. And in the logs, we should have the game area. What did we say? I think we just printed it. Right here, as you can see. The game area is 1280 by 720. Okay, so that first calculation we made up here is working. This one right here, great. And let's now test if the limit setting is working or not. So I'm gonna play the game again and hopefully not die while I'm testing this. Okay, those seem to work. And this one too. Okay, they all work. I'm also gonna test it after changing the size. So maybe let's set it to be something larger, like 1920. And as you can see, it's also working now. And we did not have to set this by hand. This is now being done in the enemy spawner. Great. Awesome. So we're gonna set the size back to be 1280. And now I'm gonna focus on testing the spawning. And you can tell that it's working because we have enemies being spawned. And currently they are going towards the player and not the center because we're doing the player one after the center. So that was the one that was set. Okay, so that's clearly working. I also want to see if the enemies are being spawned roughly from the correct position. And to be able to test that, I'm going to, let's see, let's click on the enemy spawner here. And let's set the spawn time to be something very small, like 0.1. Let's play the game and let's detach. And we can roughly see that they are coming from the correct place. It's actually a little difficult to see. Maybe just 1 instead of 0.1. And with this, you can see that it's probably correct. And we can change the game size to confirm that that's also working. Maybe make it very small. Okay, I'm going to say that that's working. So let's set the width back to 1280 and let's set the spawn time to be something like 2. I think that's gonna work fine. Okay, so that's going to be all for the enemy spawner. This was a long one, but there's still more to be done in the enemy spawner. So we're going to continue with that in the next lecture. Thank you for watching and I'll see you in the next one.